Welcome back. Today we will be discussing current electricity. So first we will be discussing what is current. So electric current basically it is represented by I and its SI unit is ampere as we know. So what is I? I is basically the amount of flow of charge per unit time. Means if this is a if this is a medium from which current is flowing through this area. So at this fixed area, the amount of charge is flowing. Let us take it delta Q. So from here, delta Q is charging. Delta Q charge is flowing from this area in time. Means from time t to t plus delta t. So the amount of current flowing through this conductor is I is equal to delta Q by delta t. This is electric current. So now we will be discussing current density. So first we will see that first one more information that electric current is scalar quantity. As we know, here let us take two wires. From here 1 ampere charge is coming and from here 2 ampere charge is coming. So means this is two wire connected to one single wire. So it doesn't matter the positioning of these two wires ends. Here we will get 3 ampere only. Hence electric current follow simple laws of vector algebra. Simple laws of algebra. So it is basically the sum 2 plus 1 3 ampere. So hence electric current is a scalar quantity. So let us now know about current density. So what is current density? Basically it is the amount of flow of charge per unit time per unit area. This is current density. So from here the amount of charge flowing per unit time per unit area from this area. This is current density for this medium. So current density and current density is represented by J. So current density, as we have found that this is I, so we will replace it I by delta A. So this is current density. Now one important fact is that from if this area, if we take this area like this, means if the medium is like this, if the medium is like this and the current is flowing through this conductor, so what's the current density? So as we know, the amount of current flowing from this area, we have to find from this area. So the amount of charge flowing from this cross section will be same as this. Means we can understand this with the example of flowing water. Let us assume this as a pipe. Water flowing from this cross section, the amount of water which has been flown from this area will be same from this also. It will not decrease or increase. So it doesn't matter. Hence we have to take this area. So if this is theta, then our delta A will be this is A cos theta. We need this one. So it will be A cos theta. Hence from this we got that J is a vector and I by A. So I is equals to so this was current density. now we will be studying about EMF, electromotive force. So what is EMF, electromotive force? As we know, in a battery, there is a potential maintained between the two poles of the battery, and as we know, battery is made up of chemicals. So due to some chemical reaction, the charges present in the poles experience some force, and due to this force, the charges move from lower to higher potential. So the positive charge get accumulated here and negative charge here. So this is due to a force, electromotive force, that is represented by Fn. So Fn, electromotive force. So as we know, when there is no field, and due to electromotive force, all the positive charge get accumulated here and negative charge there. So when the charges stop and electric field has begun, so the charges will experience a force, electric force, that is represented by Fe, electric force. So this is the electric force, and as we know, when due to EMF, when all the charges have moved across and the movement of charge has stopped, so in this stop and still position, Fe, due to the influence of Fe and Fn, when the charge, all the things have stopped, so Fn is equals to Fe, because if this thing is not there, then there is not net force 0, so the charge will move. But we have seen that the position is now static and the charges are stopped. So this is Fn is equals to Fe in electrostatic position. So this is electromotive force. Now the work done by the electromotive force in moving the charge from lower to higher potential is Fn into d. This is Fn into d, as we know the work done, and this is the work done, and as we know, this work done per unit charge, this quantity is known as EMF. This quantity is known as EMF. This is only electromotive force. So now we will see that when Fn and Fe are equal, Fe Q into E, as we know, this is equals to Fe. As we know that force electric is equals to EQ. From this we got Fe is equals to minus E, and this is electric field and this is charge. So we got Fe is equals to minus E dot E, and in electrostatic position, this is equals to okay. So now we can see that Fn, and Fn we will get Fn from here. So Fn is equals to EMF Q by D. This is Fn. So minus E, and as we know, E is equals to Vd. So we will replace E by Vd. So we get Vd is equals to Q by D. So now we will get EMF Q, this get cancelled, and wait a second. Sorry, I made a mistake here. Let us omit, as we know. this is potential is equals to V is equals to D. That's why so was it getting wrong. So this is E is equals to V by D. D and D get cancelled. So we can see we got EMF is equals to potential. So that's why when we were studying electrostatics, we used EMF is equals to potential difference. This is electromotive force. So now we will be studying Ohm's law. So now we will be studying Ohm's law. So Ohm's law states that the flow of charges, i.e. current, is directly proportional to potential difference. So and the more the potential difference will be, there will be more flow of charges and more current will be there. So according to Ohm's law, at a specific constant temperature and pressure, so V is directly proportional to I. And this V is directly proportional to I by Ohm's law was got by an experiment. So we got this. This is Ohm's law, and V is equals to IR. R is a proportionality constant, and R is known as resistance. Resistance is the property of the conductor material by which it resists the flow of charges, i.e. the current flowing through that conductor. So the resistance also depends on some factors. So if this is a wire or medium, so when the electrons are flowing like this, let us assume the electrons are flowing like this through this conductor. So as the length of this conductor is increased, means it's made more narrow. So the amount of electrons are same, but they have less area to go. So the resistance will get increased because of more collisions happening by the electrons. So the collisions of electrons will get increased due to increase in length, and due to which I will get less and less flow of charge will be there. So the resistance will be more. So resistance is directly proportional to I, and if we increase the area of this conductor, so the amount of electrons, they have a lot of area to play. So there will be less collision, and hence the resistance will be less. So resistance is inversely proportional to 1 by area. This is area of conductor. So we will plug this and we get R is equals to L by A. This is resistivity. Resistivity is the character property of that medium. This depends on the material of the medium, and it's the proportionality constant here, and it depends on the material of the medium. So resistivity is inversely proportional to conductance, because as the resistivity will increase, the conductor will conduct less. That's why it's inversely proportional to conductivity. So now we will get some formulas which are very important to solve some sums and problems. So as we got V is equals to Ri. So number of charges flowing through a conductor, let us assume it to be N, and amount of charge on one end means one of this charge is Q. So total charge will be N into Q, and N into Q. and this will be flowing from the volume of this conductor. So this is A into L. So this is the total charge flowing through this conductor. So as we know, V wait a second, let me check. So now we will be knowing about drift velocity. Let us assume that this is a conductor, and as we know, in our conductor there are a lots and lots and lots of electrons present. So there are a lot of electrons present in this conductor. So if an electron goes from here, and so there is a lot means it is a like negligible change in the speed. So the speed of one electron going from here to here will be equal to 0, because one electron will also go from there to here. That's why the U average is equal to 0, as U1 plus U2 plus Un by n is this is 0. So what is drift velocity? So V1, the final charge is U1 plus A into time V2. So the average of all the speeds of these electrons present inside, the average of all these speeds is known as drift velocity. So this is drift velocity is equals to V1 plus V2 plus Vn upon n. This is drift velocity, and now we will replace V1 till Vn by this. So we got U1 plus U2 n by n plus A into total acceleration and total time by n. So this is 0. So we get drift velocity is equals to acceleration into time upon number of electrons, because number of electrons, n is the number of electrons present in the conductor, because it is speed of first particle, second particle till n particle. So as we know, force is equals to mass into acceleration. So acceleration is equals to force, electric force. Electric force is QE minus E, Q into E, force upon mass m. So this is acceleration. So Vd is finally A minus E by m into tau. So this is drift velocity. And now, as we know, speed is equals to distance upon time. So time will be equal, time is equals to distance upon speed. So distance, let us assume it to be L or D. Let us assume it D. So distance will be D and speed will be, let us assume the speed to be V. So no, the speed is Vd. So I am telling that thing after this. So this we got our drift velocity. Actually, drift velocity is like, this is a conductor, and inside the conductor, if we will absorb one electron, then this will get collide with a lots of electron, because there is a lot of electrons present inside this conductor. So due to this collision, the path of this electron should be like this, but due to the collisions it get a drift, and as it is in opposite to electric field, so the field is like here. If the field is like here, the drift velocity is here. Hence, due to drift velocity, the motion will be this of electron. So this was all about drift velocity. So now as we know, the total amount of charge flowing through this conductor will be number of electrons n into charge E, charge in this whole volume A n. This is Q total. So we know I is equals to Q by T. Okay, and from here we get tau is equals to VDM upon, here one end is missing, we put this VDM upon 9. So this we got drift velocity. From this drift velocity we got time, and now we will use time in I from here and Q total from here. So we get I is equals to QE into AD upon VD So I think I made a mistake something. Let me check. Okay, so I is equals to time, this time is equals to distance upon speed. This is equals to distance d upon vd, speed. So NE AD upon d into vd. So we got our formula. This is a really important formula. I is equals to NVD, drift velocity, into charge into area. So this is a really important formula, and it's used in a lot of questions. So this was drift velocity and formula of I with drift velocity. So now we will be knowing dependence of resistivity with temperature. So it's a really easy. So this resistant final, this is initial into 1 plus theta delta T. So if there is a change in temperature delta T, so the final resistivity will be initial resistivity into 1 plus theta. Theta is a temperature constant into delta T. This is temperature dependence of resistivity. So this is all in today's video. Hope you liked it, and please subscribe my channel. Also like and share my videos. Thank you for watching my video, and we will continue after this in our next video. Thank you.